Hello, today we are going to be looking at how to use the method completing the square to solve a word problem. Farmer Smith has a garden. The first year his garden was 5 feet squared, as pictured below. The second year his garden was 10 feet squared. If his garden continues to grow at the same rate each year, how many feet will it be year 10? There are multiple ways to solve this problem. Today we are going to focus on solving it using the completing the square method. The shape of the garden lends itself to this method. As you can see, the garden is essentially a square with two sections missing. Let's look back at the problem. It says, if his garden continues to grow at the same rate each year, how many feet will it be year 10? In order to find the size of the garden year 10, we must determine an equation for the growth of the garden. First, let's take a look at another representation of the original model. This representation will allow us to clearly see how many square units need to be accounted for when completing the square. Now let's complete the squares. With the addition of the black pom-poms, we can see that our representation is now a complete square. We can now use the information provided in our visual to find an equation to solve our problem. We can see that year 1, the square is a 3 by 3 square, or 3 squared. Year 2, the square is a 4 by 4 square, or 4 squared. Year 3, the square is a 5 by 5 square, or 5 squared. The relationship between the year and the number of feet on each side for year 1 is y plus 2, where y is the year, or 1 plus 2, which equals 3. Therefore, the equation for the area of the square is area equals y plus 2 times y plus 2, or area equals y plus 2 squared. Let's test this equation for year 2 and year 3. Year 2. The year is 2 plus 2 squared, which equals 4 squared. If we go back to our table, we can see year 2 is 4 squared, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 4 squared is 16. For year 3, it would be y, which is 3, plus 2 squared, or 5 squared, which is 25. Let's see if this is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Great. Now we have the first part of our equation. Y plus 2 squared. In order to find the area, we must account for the square units we added to complete the square. Let's look for a relationship between the number of units added and the number of years. For year 1, we added 1, 2, 3, 4 units. For year 2, we added 1, 2, 3, 4, 5, 6 units. For year 3, we added 1, 2, 3, 4, 5, 6, 7, 8 units. Because there's no obvious relationship between the year and the number of units added, let's take a look at the sections that were added. Since there were 2 equal sections added to each square. So, for year 1, each section was 1, 2 units. Year 2, each section was 1, 2, 3 units. Year 3, each section was 1, 2, 3, 4 units. Here, we are able to see a relationship between the number of the year and the number of units. That relationship would be Y plus 1. Because that is only accounting for one section, we must multiply this by 2. There were 2 sections that were added. Since we added those at the beginning, we must now subtract them from our area found initially to find the total area for the garden. Therefore, our equation would be area equals y plus 2 squared minus 2 times y plus 1. Let's test this. For year 1, area equals y, or 1, plus 2 squared minus 2 times 1 plus 1. Or area equals 3 squared minus 2 times 2, which would be 9 minus 4, or 5. Since we have accounted for the pom-poms that we added at the beginning, we can now subtract those, which leaves us with our original garden. Let's count to see if we get 5 units. 1, 2, 3, 4, 5. Great. Let's test our equation for year 2. Area equals 2 plus 2 squared minus 2 times 2 plus 1. Area equals 4 squared minus 2 times 3, or 16 minus 6, which is 10. Let's go back to our original garden for year 2 and see if we're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Lastly, let's check for year 3. Okay, area equals 3 plus 2 squared minus 2 times 3 plus 1, which equals 5 squared minus 2 times 4, or 25 minus 8, which equals 17. Let's check our work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now that we're confident that our equation is correct, let's plug in the 10 from the original question to find our answer. Farmer Smith wanted to know how big his garden would be at year 10. Area equals 10 plus 2 squared minus 2 times 10 plus 1. Area equals 12 squared minus 2 times 11, or 144 minus 22, which equals 122 feet squared. Now we have solved our problem using the completing the squared method. Thank you very much.